semifinal round. I know you have struggling to finish your problem in semifinal round. In preliminary round, we have a 42 team, and this semifinal round is selected 8 teams to enter this semifinal round. Okay. Before we start the presentation, I want to say thank you for everybody who joined this session. Dari from SCMGLOBE, Michael Hugos, thank you for joining this session, and then Ibu Rahma and all participants who's joined in this session. In this round, besides we do the paper assessment, we also need to assess presentation from all participants in this round. Yeah. We have chosen randomly from the 8 participants. Maybe it's from, I will read the all team who entered this in this round. There is Universitas Kristen Maranatha, Institut Teknologi Telkom Purwokerto, Universitas Pertamina 1, Islamic University of Indonesia 1, Undip 2, Undip 5, Pertamina University 4, and Institut Teknologi 10 November. Nah, we will choose randomly for participant who will present the work first. Yeah. Okay, for the first team who will present their paper is Undip 2. Yeah. You have 5 minutes to present your PowerPoint and your simulation. After that, we have 10 minutes to do question and answer with a jury. Yeah. For the second team, I will choose random again after the first team who will present now. Thank you. For the first team, Undip 2, who is Aga Tertia Putra, Ananda Shafi, and Fauzan, please prepare your PowerPoint, and you can start presentation. Thank you. Please.
Can I start the presentation now?
Please.
Okay. Good morning, all judges, committee, and all participants. Here we from the Undip 2 team consisting of myself, Ananda Safi, and 2 of my other friend, Aga Tetia and Fauzan, will present the supply chain resulting from our team's discussion. So, what can next slide, Fauzan? Okay, so what is the difference between the problems in this case compared to the previous one? Because in this case, microgrid is already popular in the community. So the company finally opened 3 new warehouses in Bandung, DIY, and Banyuwangi. So there is a change in the initial on-hand parameters of Cikarang factory from 500 to 850. The challenge is that we have to design a new supply chain and keep the company running for 30 days and make the company more efficient. In addition, we also have to minimize transportation costs, facility operating costs, and the amount of on-hand inventory at each facility using the same vehicle criteria and parameters as in the previous cost. Then we will describe what methods that our team use and how much it has on the effectiveness and efficiency of the supply chain of PT Mie Nusantara. Next.
Okay, so this is a map of the route of the supply chain at PT Mie Nusantara. It can be seen on this map that PTMI Nusantara facilities are spread over 8 different areas on the Java island, and we had to find the best solution to fulfill all demand within 30 days with minimal production and operating costs. To achieve that goal, our group used 8 different methods. First, using integer linear programming to illustrate the number of trucks used. This method is used to determine the initial capacity that must be delivered to each facility. Then, in the other 7 methods, we use trial and error, but this trial and error has a solid foundation. Of course, the purpose is to make the supply chain more efficient. This trial and error method considers 7 things, namely make optimal use of truck capacity, minimize the number of trucks, minimizing on hand, minimize storage capacity, make a minimum production per day by paying attention to 30 days of demand, optimizing on-hand usage, and the last, we make the most of the 3 new warehouses.
Okay, as you can see in the slide, it can be seen that the new supply chain that we designed has generated a gross profit of 52,084 US dollars with a profit percentage of 0.53%. Unfortunately, we are not able to control the average on-hand inventory amount, especially at the Cikarang factory, and it resulting in an inventory of goods. This caused the average on-hand value to be greater and made the number of the net profit down to minus 7,502.13 Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you for Undip too to present your works. Now we can enter the question and answer session with the jury. So for a jury, there is Ibu Ira, then Bapak Anggi, and Ibu Hartati. Please, you can ask the question for the teams.
I think good you use integer linear programming before simulation, but in your report I don't see the simulation result. I only see about integer linear programming. Can you try simulation SCMGLOBE application?
Okay, sir, we will try the simulation. Excuse me, have you seen my screen, sir?
Yes, we can see it. Please simulate.
Okay, enough. Okay, thank you.
Okay, I would like to ask the question, yeah. As I see in your profit and loss report that you just still have the negative net profit, right? And my question is, what is your strategy? What is your future strategy to make this positive profit, net profit? Thank you.
Okay, ma'am. May I ask may I answer your question? Maybe our group strategy in the future, we will build a new factory, especially near in of Tanjung Perak and Tanjung Mas, and then we can move the Banyuwangi warehouses to the nearest in the Tanjung Perak, and we can use trial and error that provider the multi-stop route. Maybe that's my answer. Maybe my friend will add the answer.
Okay, is it enough? The answer? Other member, would you like to add something? No?
I think
No, ma'am. I think it is enough.
Okay, thank you. Yeah. So we have judges from SCMGLOBE, Mr. Michael Hugos. Can you would you like to add something to the team?
Yes, I've been watching the simulation, and I have looked at the way that you're approaching it. I think that you need to what the other team did they used some structured techniques like linear programming, and then they did trial and error. That's a good way to mix it up. Trial and error is the way you learn, and when you look at your on-hand inventory amounts, you can see that your on-hand inventory is very high. Look at ways to reduce your on-hand inventory. Look at ways to use just-in-time delivery from your delivery trucks. But I think you're off to a very good start.
Yes.
Bu Tati, do you have any question? Okay. Okay. I think it's enough, yeah, to the first team from Undip 2. Back to Pak Yodi. Thank you. Thank you, Undip 2.
Okay, thank you for first team who will present your works, and thank you for Mikael that giving some question for the team. Now, I think we will continue to the second teams who will present their works. That is Pertamina University 4. Yeah. For the team, please prepare your presentation.
Am I audible?
Okay, after you're ready, we will start the countdown.
Okay, is that my screen is shown on your slide?
Yes, it's clear. You can try in full screen mode. Yeah, thank you. It's okay.
Okay, I'm just going to start this presentation. The amateurs discuss tactics, while the professional discuss logistics. Assalamualaikum warahmatullahi wabarakatuh.
Good morning, everyone, and honorable to all the judges and also the audience. So today we are coming from Group 4 from Pertamina University, and we are going to deliver our design of supply chains that we have been made before. So I'm just let you to know about the background first. So here, the Kribo Noodle Distribution Network by PT Nusantara Noodle, where they will send the Kribo noodles to their 7 warehouses from the factories. By this design, we found some problem that we have been met before in the problem association diagram, and we just finally decide to use the simulation model because the simulation model is giving more flexibility to know the system performance. It have no failure or cost and imitates the behavior of interest experimenting. And by this, the simulation method, we aims discussions is to determine the best supply chain design in distributing Kribo noodles by cutting the inventory and operational costs in order to achieve the better profit. And here, the description of the current supply chains and its initial situation. In the very top pictures, as you can all see the initial route by the problem given, and they have 3 new warehouses, while they hasn't designed the route yet. And this one is the initial illustration route, where the factory will send directly to the Tanjung Emas and also Tanjung Perak, while for Tanjung Priok and Merak will send in the one-time delivery. And this is the initial chosen route that we have been set before in the previous case, and we found that the optimal route for this one on the green one is direct shipping to the single destination. And we've solved this before with the linear programming. So to find the best scenario, we finally decide the 6th scenario. And by this 6th scenario, we run the mathematical model. The mathematical model is shown on the slide, as you can all see. And we done the mathematical model with the Excel data solver. And this is the result of the mathematical model shown by the data solver. And finally, we got the variable cost in the minimum cost at the first scenario, where this is the design of the first scenario, with the total variable cost 568.8. And in this scenario, there will be distribute the process to carry out it, send the product directly to each warehouses, all known as the design of direct shipping network model to single destination. And finally, we end up with this report, the monthly report and loss report plus KPI performance. As you can all guys see in this report, we hit the minus point, but we can guarantee that the quantity of demand in every warehouses are filled because it is all covered. But the consequence, we have the minus point. And the supply chains models also have cutting the inventory cost and operational cost. As we back to the resilient concept that we know if we are having full impact hit, the performance often drop precipitously. It is based on the reference of Joseph Sevi and James. And also based the concept of resilience, the company need to do recovery preparation. So in the next one, there will be a better profit that will be shown by the company. That's all from our team. Thank you for your attention. I'm giving back to the moderator.
Okay, thank you for the second team, Pertamina University for your presentation. And we will continue to question from the judges, please. Judges.
Okay, thank you. For University Pertamina 4 ya. Hello Rohma, Hermawan, and Syahrin ya. So it's very interesting, yeah, that you
Yes.
come out with the several scenarios, yeah, to do, yeah. So from all the scenario, how you choose which scenario is the best?
Okay, thank you so much for the question. I just like to directly answer the question. So, as what we have designed before, that the first case given in the before the semifinalists, we got the best network as shown here, the green one, and the case just given that we need to build 3 new warehouses in Bandung, Jogja, and also Banyuwangi. Because we have already got the best route for the warehouse in the port, so we just focus in this stage to have the red box design. So we need to, on the right side you can see, we just need to adjust the red side because we have the new facility there. So how we got this best scenario? To identify the best scenario, we use the mathematical model for the transportation and by the tools of Excel data solver. In here, we identify by the lowest variable cost. The variable cost which consists of transportation, rent cost, and holding cost. The smallest variable cost indicate that the scenario are the best. So the best scenario is placed for the first scenario, which show the smallest variable cost. Then the first scenario will be chosen as the distribution route for the transportation model.
Thank you.
That's all, Miss.
Okay. I want to ask you, you saw the variable cost of the transportation. How about the cost of other like the factory and the warehouses?
Well, thank you so much, Miss, for the question. It is about how we are dealing with the warehouses and factory. So the warehouses and factory itself, it is the fixed cost. So this is not considered as the variable cost. Then the fixed cost is not totally in the variable cost. That's all, Miss.
Okay, we've seen your net profit is very large, and how do your strategies to rise to get the positive net profit, to improve the net profit?
Okay, thank you for the question. I will try to answer. So to increase the net profit, we have a strategy to maybe build a new factory or new distribution center, and when we try to place a new factory, we will place the factory at between Surabaya and Banyuwangi. So from the distribution center, they can from the new distribution center, they can transport to Surabaya and Banyuwangi, not directly from factory in Cikarang. And for the next strategy, we need to do a forecasting about the demand, so we can prepare for the quantity on hand that we need to prepare for the next month. Maybe that's my answer.
Now we will hear the feedback or the question from Mr. Hugos. Michael, please.
Yes, I think you're off to a good start. I think that you should do a little bit more experimenting. You're making good use of the Excel solver. Plug those numbers into your supply chain model and run the model again and see what kind of answers you get. If you take the next step, you've done the analysis, now put your analysis into the model and run the model again and see if you can do it a few more times and keep improving from the simulation results.
Okay, thank you. The last question. Is there any difficulties during the solving the problem for the participant?
Well, thank you for the questions about the difficulties we face in the running the simulation itself. So the main difficulties that we think by designing the new supply chains is that we got the quantity on hand is smaller than the demand itself. So in case we need to cover all the demand, we have raised the minus point at the profit. This is the consequences, because we want to focus to cover all the demand where we can have customer satisfaction. So the profit will be getting lower because the quantity on hand that delivered to each facility is smallest than the demand itself. Then it will impact to the operational with highest value.
Thank you. Thank you, Pertamina 4, University of Pertamina 4. Thank you for your answer and presentation. Next, Pak Yodi.
Thank you.
Okay, thank you for the second team who finished your presentation. It's a good presentation from University Pertamina 2. Now we next to the third team who will present the works, that is Institut Teknologi Telkom Purwokerto. For the team, please prepare your presentation. And I want to remind you, after you finish your presentation, please stop your share screen so we can show the time, countdown time. Thank you. Please. Your voice still not heard by us. Please check.
I'm sorry, I forget to unmute my mic. So okay, thank you. Good morning everyone, and the honorable judges and Mr. Michael Hugos here. We are from Institute of Technology Telkom Purwokerto. Will present our solution for the problem case 2. So as you can see, this is where we start. At problem case 1, we already redesigned this supply chain, but only with the 4 ports. And here in the case 2, we get 3 additional warehouses. And the first problem that we need to solve is to create a distribution channels for the 3 additional warehouses because they still don't have any distribution channel yet. And beside that, there is a build of inventory in almost of facilities, and there is also an excess production for products in Cikarang factory that result in increased inventory and facility costs. So that was our initial problem, how we should improve it. So this is our first try and first solution. As you can see in the PowerPoint, our supply chain at this stage can be run until the 30th day, but it still have a lot of things to fix. Some of the things that we need to fix in this solution is the net profit and the gross profit that's still negative, and it's like a huge minus. And then there is a lot of accumulation of goods in large quantities. There is a lot of unused storage space, and vehicle operation cost is still very high. Almost all warehouses, including factories, have a surplus supply so that on-hand inventory will continue to grow. And the last is average on-hand inventory amount is too large, so holding costs due to inventory is also large. So our ideal system is, of course, a positive net profit and gross profit, a stable on-hand graphics, and no build-up inventory. We try to make the ending inventory on hand as low as possible, and then vehicle operation costs and smaller than before. The maximum storage capacity and average on hand inventory amount is successfully reduced. So it is our ideal system. How we achieve that? We try a distribution system with different number of truck type, drop quantity, and delay between departure to find the optimal distribution system with a combination of average on-hand inventory amount and vehicle operation cost to minimum. And we ensure that average on-hand is low and stable enough so that maximum storage capacity can be reduced. 3. Comparing between distributions using EOQ and without EOQ, then combine the two of them to find a distribution system with the smallest vehicle operation. And the last, we try different combination of distribution system. So this is our last try because we cannot finish it. This last supply chain is the most optimal option that we can get. The supply chain can run and work more efficiently than previous supply chain and reduce existing losses, even though it has not been able to get a positive net profit yet. And there is still a build-up of goods at warehouse Bandung and warehouse Jogja, which cause the holding cost due to inventory is still very large. On the other hand, gross profit is still very small to cover the large inventory cost. So for the conclusion,
1 minute left.
For the conclusion, Mbak Melina.
As we have seen in slide presentation before, from the existing problems, we can draw the conclusion that the streamline a supply chain and all aspect is an attribute of the supply chain must be considered by properly. Fully redesigning the supply chain starts with envisioning what it needs to become, and that we identification the problem, setting the goal, and try to implement the redesign strategy. It's a redesign supply chain stage that we do in order to maximize the results of this redesign. But the whole strategy cannot be done because of the limited time we have.
Your time is up. Okay, thank you for the third team, Institute Teknologi Telkom Purwokerto, that is Ade Tiara, Bergas, and Melina, who has present their works. Now for the Q&A session with the judges, please.
Okay, thank you, Pak Yodi. Ade Tiara, Bergas, and Melina, hello.
Hello, sir.
Okay,
Hello, sir.
I have a question. In your report, I see your strategy is use 20 vehicle, right?
Yes, you are right.
Okay. Can you explain about your strategy to use many vehicle, I think?
Yes, I also admit that we use so many vehicles and it makes the vehicle operation cost is very high. It's not our finished solution actually because we try to fulfill the demand of the every facilities like the warehouses and the port, and that 20 vehicles is our less like our first time that we can fulfill the how I can say it, fulfill all the demands. So we haven't improved the uses of number of vehicles. So we just use the first solution that we get, although it hasn't been improved yet. So yeah, that's it.
Okay, thank you.
Oh, sorry.
Okay, I have a question ya.
Dari mana nih?
Beside the on-hand inventory, yeah, on-hand inventory that we revise early in the night in night, yeah. What is other difficulties for your team to solve this problem?
If I can be honest, actually my team is not from a logistics supply chain background or educational background that focus on supply chain. So after seeing other group presentation, we realized that there is so much like method that we can use, and it will also make our problem solving more efficient. So instead of using that method, we use the manual and like figure it out manually. So it's really cost much of time. It's like that. Thank you.
From what program?
We are from information system.
Okay. Why do you interesting to join this logistic and supply chain competition?
It was because my professor is recommend it to us in our class, and because I think the subject the subject is really interesting, and I think why don't we try to compete in this competition and learn how can I say, how other people and how the supply chain is really work in the real life, and not only what we learn in the class. So yeah, we just want to learn and get more experience.
Okay. How about the software, the SCMGLOBE? Do you find it very easy to understand so that you can solve the problem? Either otherwise, either you are not from the logistic and supply chain field. Is it
Yes, yes. Sorry, I cut here. I think the SCM Globe application is very interesting because at class we have not used any supply chain simulation, and when we first try the SCM Globe, we really get addicted to it because we find it's really fun to like solving the problem and then comparing the other solution and get what is the best solution that we should solve the problem. And I think it's really easy to understand, and the user it's really user friendly too.
Okay, thank you.
You
Mr. Hugos, do you have any feedback or any question to this team? Thank you.
Yes, I think that, again, you got off to a good start, and one of the things you should do when you were looking at the KPIs, I was noticing that your percent increase in inventory in both times that you showed those KPIs, the increase was very high. That's always an indication that perhaps you're making too much product and you could reduce your product production rate. And then that would also bring down the transportation because you wouldn't have to move the product, and it would also bring down your rent cost because you wouldn't have to store that product. So looking at those KPIs is a good way to think about how you should change your supply chain design.
Okay, thank you very much, Mr. Hugos. Okay, thank you very much from Institut Teknologi Telkom Purwokerto for your presentation. Next, Pak Yodi.
Okay, Bu Ira, thank you. Yeah, that's a good example from Institute Teknologi Telkom Purwokerto. Even they're not on a logistic study program, but they have fun with this supply chain simulation. Yeah. Okay, now we will continue to the fourth team who will present their works. That is Universitas Kristen Maranatha 2. For the team, please prepare your presentation. We will start the countdown if you have already. Please.
Have you seen my screen yet?
Okay, check your voice first.
Have you seen my screen yet?
Okay, that is clear.
Okay. I will start the presentation. Good morning, ladies and gentlemen. We are from Universitas Kristen Maranatha Team 2. So we would like to present about the logistics supply chain study case in PT Noodle Nusantara. Before that, let me introduce the team member. I'm the captain for this team. My name is Nunya Manrati, and my two other partners are Shania and Christy Caroline. First, we will tell you about the description of the current supply chain. So, PT Noodle Nusantara is the company engaged in production of food, with one of its product is Kribo Noodles. PT Noodle Nusantara has one factory located in Cikarang, also 7 warehouses located in Tanjung Mas Port, Tanjung Perak Port, Tanjung Priok Port, Merak Port, and the newly added facilities are located in Bandung, Yogyakarta, and Banyuwangi. So this is the current supply chain of PT Noodle Nusantara. So from the given model, the newly added facility still doesn't have any vehicle that can deliver the product. So we need to add the vehicle to the newly added facility. And when we try to run the simulation, one of the problems that are often found is the shortage of product in several warehouses. So some alternative scenario we use during the experience are change the drop quantity of the truck, change the size of the truck, add new trucks, change the storage capacity of existing facilities, change the production rate, and change the shipping type to multi-drop.
And here are some strategies for fixing the current supply chain. First, we can add the truck at some facilities such as Bandung, Yogyakarta, and Banyuwangi because the three of them is a newly added facilities. Next. The second one is we can change the drop quantity. Changing the drop quantity at some facilities based on the demand at the warehouse, delay between departures, and number of vehicles that deliver to that facility. And the third one is change the shipping type to multi-drop. We decided to use a multi-drop deliveries in some facilities because the location of some warehouse is quite far from the factory. So using a multi-drop route would help in decreasing the transportation cost. And the fourth one is change the storage capacity of existing facilities. Reduce the storage capacity because all the facilities have a warehouse capacity that is too high compared to the average on-hand inventory. Next. And the fifth one is change the production rate. Changing the production rate from 2,000 to 1,400 because if we continue to allow high production level, it will cause a build-up in storage at the factory. And the last one is change the truck size. So we can adjust the truck size to the number of warehouses visited and the demand. And here is the analysis. First is about intermediate. Tanjung Mas has a lower daily rental cost, so Tanjung Mas become intermediate for distributor point. Next. And the second one is about multi-drop. The delivery to Banyuwangi warehouse also passes through Tanjung Perak Port. Tanjung Mas Port can perform the multi-drop in order to save vehicle costs. We also do the same thing to Cikarang factory to Tanjung Priok Port and Merak Port using the same truck to save vehicle costs.
Okay, this is the result and conclusion about gross profit. The increase in gross profit is because we are trying to make changes to the model, such as changing the values of several parameters by minimizing storage capacity in the factory and warehouse, adjusting the number of shipments, changing vehicle size, adjusting drop quantity, and changing production per day. So this is a net profit. The reason why the net profit result in this simulation is negative because the transportation. There is still a lot of room to improvement because the current route and the selection of transportation modes are not optimal. The next one is route. Decision making regarding single drop or multi-drop routes may also not be optimal, where there are facilities that may be able to send to other facilities but are not performed. And then this quantity on hand. Quantity on hand currently make it difficult to do a lot of shipping, especially from the factory, because if too many products sent from the factory can make the appearance of stock out on day one. So if we continue the simulation with the supply chain network that has been updated to more than 30 days, we might find errors because from the simulation result, it can be seen that the inventory level in some facility has a tendency to decrease, which can cause stockouts in some facility. So that's all from us. Thank you for your presentation.
Okay, thank you for Universitas Kristen Maranatha who finished their works. Now we can continue to Q&A session with judges, please. Judges.
I want to see your previous about that conclusion because you sent the different presentation to us about the conclusion. Okay. I think. Oh. Okay. Next. Okay, stop. Okay, I wanna to ask you about the transportation. You said here like that the selection of the transportation modes are not optimal. Okay, how do you make the optimization the transportation here? Yeah, I'll once more. What's your strategy to make the transportation optimal? Because you said here the current route and the selection of transportation modes are not optimal. So I'm gonna ask again, how do you optimize the transportation modes and the route?
Okay, thank you for the question. Maybe a few things that we can do is because we use intermediate location that transfer to another facilities, maybe we can try to change to use other warehouses as a intermediate location. Maybe the one that we use now is not the best one, so we must try other warehouses to be a intermediate location. And also we use multi-drop shipping, but I think the multi-drop routes that we use now still have a lot room of improvement, because maybe there's a few locations that we can do the same thing like multi-drop, but we still have not do that yet at this model.
Okay, Vira. Okay, team from University Kristen Maranatha ya. Do you have any? How do you feel when you are solving this problem during this competition? How do you feel?
Actually, we face a lot of difficulty because the difficulty we faced during solving the problem was how to determine the drop quantity for each vehicle. So we must try a lot of trial and error, and it takes a lot of time. So it's the difficulty we face, and also after seeing the other teams solve their problems, we realized that there's a lot of things we still need to learn about supply chains, because we're not from the uh, programs that focus on supply chain. So after seeing the other team, we realized that, oh, there's a lot of things we need to learn about the logistics supply chain.
From?
We're from industrial engineering. So we learn about supply chain, but not in depth.
Okay, Booster team. Okay, your team use strategy for transportation is multi-drop transportation. I think we can see in one route. Yeah, you try to drop in Tanjung Mas and then Banyuwangi. Yeah. Nah, how your team decide how much quantity I must drop in Tanjung Mas? How much quantity will drop in Banyuwangi in one route? Do you use method or trial error?
We use trial and error a lot of time. So
Okay. Okay, thank you.
Okay, thank you. For the feedback from Mr. Hugo, do you have any feedback? Please.
Yes, I could see that you're engineers. You had a very good framework for analyzing the problem. You had some good insights from when you showed your analysis, and perhaps you learned something that transportation is often one of the largest costs in any supply chain. Besides inventory, transportation usually is the largest cost. A thing to consider would be, what if there was a different mode of transportation? What if there was rail transportation that went from one end of Java to the other? Would that have a big effect on your business, and would you then be able to make a profit? Those are some things to think about.
Okay, thank you, Mr. Hugo, for the feedback. Okay, I think that's enough for University Kristen Maranatha. Thank you for joining us, and thank you for your presentation. Back to Pak Yodi.
Okay, thank you for Ninyo Manrati, Permata, Shania, and Christy from University Kristen Maranatha who finished your presentation. Now we can continue to the fifth team, so we will present their works. This team for the prelim round have the biggest profit. Yeah. Now you need to prove your result in this round. Okay, that is Islamic University of Indonesia. Please, for the teams to prepare your presentation.
Okay, sir, thank you.
Okay, sir, we're ready to present.
Okay, this is clear.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Hello, it's an honor for us to present in all of this great audience here. And thank you, judges, for the time. Okay, let me introduce my team. Hello, my name is Retnodia, and there is my partner there, Mas Raffi Hafiz Siregar and Mbak Tasha Aufa Nadira. We are from Islamic University of Indonesia. Welcome round 2, how to handle a new market in Noodle Nusantara company. So we will discuss about 3 points that we think it is important in this case. So next slide.
So we will discuss about description of the current supply chain of Kribo Noodle and its initial situation. The second is assessment of problems in the current supply chain and strategy for fixing these problems. And the last is the new supply chain network of Kribo Noodle and why it performs better to meet the company business needs. With the difference in the previous case, in this case, Kribo very well known. So Kribo Nusantara company decided to build 3 warehouses in Bandung, Yogyakarta, and Banyuwangi.
Okay, for description of the current supply chain of Kribo Noodle and its initial situation, continuing from a case study in round 1, PT Noodle Nusantara have 4 ports, that is in Surabaya, Semarang, Serang, and Jakarta. And PT Noodle Nusantara has 1 factory in Cikarang. And for the additional, the PT Noodle Nusantara have 3 warehouses. There are Bandung, Salatiga, Yogyakarta, and Banyuwangi. Okay.
Okay, based on the initial situation there, we found several problems related to the supply chains in Noodle Nusantara factory. They're like run out of Kribo noodles in DC warehouse Banyuwangi, and you can see in the graph here the total quantity on hand is high, same like the demand, but it is different about the supply because it is too low. And we found that the model cannot run optimally for 30 days, so we have to remodeling it and give the strategy. Next slide.
So the strategy is first, our strategy in addition to compare the previous and subsequent simulation by doing a trial and error. And next, we adding the number of trucks and change the type of trucks according to the demand at each warehouse and port. Next, we also adjust the delay of departure for each transportation that we use. Next, we also make Tanjung Perak Port as a temporary stop before heading to Banyuwangi because Tanjung Perak Port is the closest to Banyuwangi with its lower daily rent cost. And next, we also reducing the warehouse capacity to minimize the on-hand cost. So as you can see, the result is the latest model has lower cost, but the transportation cost is higher than the first model because we add number of trucks, but it can lower the total cost and can fulfill the demand.
1 minute left.
Okay, this is the last result from our model. We can see our gross profit is 1.11% and the cost of the facility storage and operating cost is 181,000 and 350, and vehicle operating cost is 6,000 and 695. That is from us. Back to Mbak Eno.
Okay, thank you. So that's all about our presentation today. I give back to the moderator.
Okay, thank you for the 15 from Islamic University of Indonesia. Now we continue to the Q&A session with the judges, please.
Okay, thank you. from Islamic University of Indonesia ya. Halo Raffi, Hafiz, Tasha, Aufa, and Retno Dia Purwaningrum. So first, I would like to ask you, what study program do you from?
Okay.
Yep. Okay, hello, Miss. We are from industrial engineering.
Okay. From industrial engineering ya. So do you use any other methods as I think in industrial engineering we also learn about the operation research ya. Do you use here or no?
Okay, we use the economic order quantity, but that is bit with logical when the example um, when in the Bandung and the quantity on hand is 500 and the demand is 300, so we will reorder in the day 2 like that, ma'am. The method that we use in this model.
Okay, you use AOK ya. Okay. Okay, any other question, Pak Anggi?
Okay. Islamic University Indonesia. Okay. I see your strategy to fix the problem is reducing warehouse capacity. Okay. In strategy number 4. But can you see the BL report about presentation change of inventory on hand? Yes. I see presentation change of inventory on hand. It's big. It's bigger. Okay. Okay. My question is, what strategy you will choose to increase or decrease percentage change of inventory on hand?
Okay, thank you, sir. For the answer is the main problem in the quantity on hand is in the Cikarang factory, because Cikarang factory has high demand on hand but low demand. So the first our strategy is decrease the production and decrease the increase the number. Decrease the number of delay the transportation. So the product will be shared fastly to the other location. So the in Cikarang factory has lower quantity on hand, because in our result, the less quantity on hand in the Cikarang factory has 2,000, and the quantity on hand before is only 500, and that is the main problem as the main problem in this case study. Like that, sir. Thank you.
Okay. Any difficulties using this software, this system, compared to previous software that you use?
I think we don't have much difficulties because the software is easy to use, and the software many tutorial on YouTube to play or to use this software. But the biggest difficulty when we do the case study is our team is focused to fulfill in the Bandung and in the Yogyakarta. But the main problem is in Banyuwangi, because Banyuwangi has far distance from Cikarang factory. So to fulfill in the Banyuwangi, we must have many strategies. I think we can call the strategies is gotong royong, because for the full fit in the Banyuwangi, we can pick in Surabaya, Yogyakarta, and Cikarang. So that is maybe that is some difficult that our team when do this case study, Miss.
Okay, thank you. Now we will hear the feedback, feedback from Mr. Hugo for this team, please.
Yes, I can tell you're also engineers. I always respect the way engineers are trained to analyze problems. So you did a good job there. I think you also were wise to use the economic order quantity equation. That is a good way to figure out the amount and frequency of product deliveries to the different locations, the different warehouses. And then your ideas about synchronizing production with overall product demand is a good strategy. If you keep going in that direction, I think you'll find good results.
Okay, thank you, Mr. Hugo. Thank you from Islamic University of Indonesia for your presentation. Back to Pak Yodi.
Okay, thank you for UII in abbreviation for your presentation. That's a good presentation and a good result too. We hope the other teams, the next team will give the better presentation. For the sixth team is Institut Teknologi 10 November. For the team, please prepare your presentation. Aufa, Andina, and Arnoldus, please. Okay, please check your voice.
Test. Can you guys hear me? Hello?
Hello?
Okay.
Okay, it's clear, please.
Okay, is the time already started? Okay.
Yeah.
Good morning, everyone. My name is Alvarez Rehaldi as the representative of the Changers team from Institut Teknologi 10 November. Today, we're going to show you about our result of how to handle new markets with an adjustment of additional warehouses. So first thing to do, we must identify what is the main problem of this case. We use many frameworks such as element of problem analysis, input-output diagram, and causal loop diagram to know about what is the correlation between the variables. And the result is we know that PT Kribo Nusantara, the main problem is to fix the distribution network, which still can connect and fulfill all demand nodes. With the additional number of warehouses, the problem scope of PT Kribo Nusantara has become more complex. So we can see from the presentation with the element of problem, there are several things to be considered to solve this problem. So we have to set the situation goals to help us know what is action plan to design. With the gap analysis, we know the desired situation, compare with the current situation, and we can see the gap. So we know what is exactly the action plan that we need to design. And it is concluded that several things must be adjusted to achieve the desired situation. High fulfillment rate, low expenses, and low hand inventory are some of the situations that are expected in designing efficient and responsive SCM for PT Kribo Nusantara. We know from the gap analysis that the majority of the action plan is to adjust the decision variable to achieve the desired situation. So from the model of improved solution, mathematical analysis approach is used to help determine the decision variable. We use economic order interval calculation and linear programming to help find the best combination of trucks going to a route assuming full truckload condition. And then we know that how much the number and type of the trucks we must use. We use the time between departure as the basis input of the simulation. And from the presentation, you'll see the formula to calculation the time between departure and the result of how much the truck that we use and type of trucks that we use. And then after we put in the base of the calculation to our simulation, we slowly changing the decision variable one by one to achieve the 30-day runtime and lowest possible cost. This graphics and table shows our final vehicle route strategy use. And the supply chain model can successfully be run using SCMGLOBE for 30 days with just-in-time approach. We can see the new distribution network and the result of the SCM model simulation. And this model, in terms of its ability to run for 30 days and fulfill demand, is very optimal actually. But based on the company's financial reports, the company experienced a slight loss at the net profit. This is because the initial on hand at the factory or Cikarang factory is not too much, so that the company is not able to do the direct shipping to the facilities. So routes need to be formed to fill in the blanks instead of getting goods from the same resource, so that operational costs tend to be higher. However, our strategy, by making the overall manufacturer or distributor markup to 15%, there are significant results shown in the table below. Okay, so the conclusion is, it can be concluded that first, the proposed supply chain model has been able to connect all demand nodes by allocating some products for direct shipment and some other being consolidated and transferred from other warehouses based on the network that we also present. And the shipment of Kribo Noodle products is performed using full truck load size of both three types of trucks, large, small, and medium. The adjustment made for the improved model are based on the mathematical model to find the close to optimum order interval, or EOE, which determines the delay between arrivals of each truck and determining which type of truck is most efficient. By running the model using SCMGLOBE, the model can successfully for more than 30 days. And then the last one is the simulation output can fulfill all demand from each part with low average inventory and positive gross profit, even though the net profit is still minus due to high cost of facility and operational. By increasing the market price in 50% to all facility and considering the distance of different warehouses, the net profit gain can be higher. It can be said that the proposed model has better supply chain performance than the initial. That's for all from us. Thank you. Assalamualaikum warahmatullahi.
Okay, we continue to the Q&A session, please.
Okay, thank you. From Institut Teknologi 10 November, Aufa, Rais, Anindya Aulia, and Arnoldus Arka Wimba. I assume from seeing your report, I assume that you come from industrial engineering, right?
Yes, it's true. We are from industrial engineering.
Okay. But I see in your P&L report, yeah, there's also still have negative net profit, yeah?
Yes.
What do you suggest, or what do you have any strategies, other strategies that can be used to increase the net profit?
Okay, so first thing is, we know that the main problem is the initial on hand and the less initial on hand in Cikarang factory. We assume that the factory, because it is not capable to fulfill the demand, so we must to spread the route to have target to fulfill all the demand of the facilities. And then we're assuming that the markup or distribution can be increased like all in 15%. So we can, if we can again to minimum our costs, we can increase our profit or our margin based on the markup, so that we can still the best net profit as we show that in the Excel.
May I add something? Maybe another strategy that we can have for the model is like in this case we have limited option for the transportation mode. Maybe from seeing the location of the warehouses, it has potential for using any other transportation mode, such as because there are some ports, maybe we can use ships, or because it is only in Java, maybe we can use rail because they have bigger capacity, and so it can lower the cost for each unit of the product.
Okay, thank you for your answer. Yeah. Very good question. A very good answer. Sorry. Pagi, okay. Any feedback from Mr. Hugos?
Yes, I think you're very wise to look at other transportation modes. Ship and rail, when they are possible, will be less costly than obviously than truck or airplanes. And I thought you did a good gap analysis. You have organized your thinking well. You are looking at redesigning the network, which is a wise move. And then your application of some classic equations is also good. Keep going in the directions that you've already sketched right now in this presentation.
Thank you, Mr. Hugo.
But one other question. I see that in your report, you provided the causal loop diagram. Yeah. Is it?
Yes.
Do you think is it the condition is very dynamic, or what? Why do you use causal loop diagram? Because it's something used for describing any system that has the dynamic area, yeah, dynamic system.
Okay, so we use the causal loop diagram to see the correlation with the all the variables, and then because in the reality it is a lot of uncertainty, like the total travel time and the total distance time. And also when we see the website of and the explanation of the SCMGLOBE, the frequency asked question, that explain that there are possibly error or undelivered things to the facility. So we assume that there are uncertainty to this model. So, but the purpose of the using of causal diagram is just to see the correlation, so we really know what is the consequences that if we change the decision variables. I think that's it.
Thank you very much for your answer. Thank you very much from ITS to your answer and your presentation. Back to Pak Yodi.
Thank you.
Okay, thank you for Institute Technology 10 November. That's a good presentation. Thank you for Mr. Hugos too and the judges. Now we can continue to the seventh team who will present their work. That is Undip 5. For the team, please prepare your presentation.
Okay, is my screen already shown?
Yes.
Okay. We will start. Do it right by doing it in timely manner, and that's also what we need to do in supply chain. Good morning, the honorable judges, LSC committee, and participants. First of all, we are from Team 5, Undip 5, want to say thank you for the opportunity for us to be able to present our work results today. So our team consists of me, Clarissa Amelia, and my friends, Filiana Uli and Scholastica Devi. So for the next slide, we will be explained by Scholastica.
Okay, thank you, Clarissa. So from the study case, we know that the problem is PT Noodle Nusantara now are well known, and it has 3 new distribution centers. And the company wants to create supply chain that efficient and give huge profit by minimizing the cost and inventory. As you can see here in the slide, there is a picture of our current company supply chain. The factory is still located in Cikarang, and it produces one product, which is kripo noodle. And then from the west, we can see there is Merak Port, then Tanjung Priok Port, Tanjung Mas Port, Tanjung Perak Port, and 3 distribution center, which is in Bandung, DIY, and Banyuwangi. All facilities has different daily rent, daily operating costs, demand, quantity on hand, and also this distance between each facilities that is different. So we want to give some solution to optimize the supply chain, and it will be presented by Filia. Next.
Okay, from the current situation that has already defined before, we can conclude that the problem that occurs is that we have to design a supply chain system with new distribution center and improve efficiency and profit, lower transportation and facility costs, also lower on-hand quantity. From the problem that has already defined before, we conducted 6 new solutions or 6 new strategies, which are first, create minimal on-hand quantity and facility storage to minimize inventory cost. The second one, optimize the frequencies of every vehicles and still have corresponds with vehicles. We also have to optimize the vehicle size and types. We also have to optimize the number of productions per day, so it's not exceed or subside the demand per day from each port, factory, or distribution center. And then we have to optimize the delivery amount or the drop quantity for each location. And the last, we have to choose which route is the best to minimize transportation costs. This slide shows change in facilities and number of truck used in each facilities. In our newest supply chain model, maybe previous one, yeah. In our newest supply chain model, we use 21 vehicles, which means we use 21 routes. With that amount of vehicles and routes and our strategies that have already been used and described before, we succeeded to run the simulation until more than 30 days. And the result shows like the table below. As we can see in the table below, the utilizations of the storage is being well used, and the biggest utilization is in Cikarang factory. Next.
So we have already simulated the all the solutions, all the 6 solutions in the SCMGLOBE, and the result we get is gross profit $128,000, and the gross profit is 1.29%. Maybe that's all from us. Thank you.
Okay, for the team, please stop your screen, please, first. Okay, now we can continue to the Q&A question with judges. For the judges, please.
Okay, tim Undip, Clarissa, Viala, Scholastica. Okay, I have one question. In your solution, you try to optimize the frequency of every vehicle and then optimizing the vehicle size and type. Can you explain what strategy you take to optimize the frequency of vehicle and vehicle size?
Okay, thank you for the questions. Maybe I will try to answer. The strategy for us to maximize and optimize the transportation or the vehicle size is with trial and error actually, but we use the graph that provided by SCMGLOBE so that we can control what size of the vehicles and the drop quantity or the frequencies that we should choose, maybe like that. or maybe other members want to add any answers.
Okay, maybe so for the after we run for the first time and then we see the graph of the result, and then so for the example, if the graph is going down, then it means the inventory in the distribution center is not fulfilled, and then by that we can make a solution that maybe we need a bigger truck, or we can minimize the frequency, minimize the delay time of the truck transportation, like that.
Okay, is it enough?
Yes, enough. Thank you.
Thank you. Yeah. So from Undip 5 ya. Okay. Let me see. Yeah. Okay. Can you tell us what is your good experience while doing your problem solving the problem?
Maybe for me individually, the good experience is when this is the first time I'm using the SCMGLOBE application. So with solving the problem, I can actually experience and know how to use the software, and I also know what is the variable that is important for us to consider to design a great supply chain.
Okay, that's for the good experience, yeah. But is there any bad experience or difficulties while you're doing this study, this case?
Okay, maybe not the bad experience, but just the challenging experience, maybe I can say. I think SCMGLOBE is unable to undo the thing that we have already done before. So sometimes when we yesterday trying to find the solution and we try to change the parameter that can be changed, and then we want to get back to the parameter before, we sometimes forget somehow. So but the SCMGLOBE cannot undo that. So yeah, it makes that more challenging. Ma'am, thank you.
Okay, I just read the your report. It said here that the utilization of all facilities are very good. The 27 use storage well. Now, I want to ask, what's the biggest percentage of the utilizations of all the facilities? What's the largest percentage of the using of utilization, the inventory? Because I see here it's until 88% in pabrik Cikarang.
Yes, for the largest is in pabrik Cikarang. We still have maybe high on hand inventory on pabrik Cikarang.
Okay, maybe I'll change the question. How much? How the largest percentage the performance of each the utilization of each facilities? Is it until 100%?
For as far as we know, um, I'm sorry. Maybe if you can repeat the question.
Okay, there is the performance indicator called utilization. Okay, how the biggest utilization all the facilities which we can still it's very good, or until what percentage that the facilities we need to make it larger or to build a new one.
For us, for the whether for in our goal is to reduce as much as inventory costs. So first, we try to lower the on-hand inventory, and then the lower it is, the better it is. So when we have lowered the on-hand, and we make the on-hand stable, and then we can minimize the maximum storage, so it will minimize the rent costs like that. Thank you.
Okay, thank you for your answer. Now we will hear the feedback from Mr. Hugos, please.
Yes, I think that you understand what to do. You've got a good idea that you want to lower your on-hand inventory, you want to lower your storage cost, and you're learning an important lesson about the real world, which is especially in food supply chains, profit margins are low. So the holding cost of excess inventory will quickly destroy the profit of a company like this company here in the supply chain. So it is always something to keep in mind. Also, to your team, thank you for your feedback. We are always listening to the things that people like and do not like. And your ideas about how to make SCMGLOBE better are always appreciated. I heard you when you said you wish there was an undo feature. We're working on that.
Okay. Okay, thank you yeah, for your feedback. Thank you from Undip 5 for your presentation. Back to Pak Yudi.
Okay, that's a good presentation from Undip 5, I think. Now for the last team who will present the works, that is University Pertamina 1. We expect the best presentation from you. Please prepare your presentation.
Sorry, before my slide is already seen, sir.
Okay, still on process. Wait a
Okay.
second. Okay, please try to make a full screen.
It's already seen.
Okay. Okay. Sorry. Still loading, sir. Sorry. Sorry, before.
Okay, have any problem to?
Still loading, sir.
Okay.
Oh. Okay, already seen, sir. Now.
Yeah, that's clear. Now, please start your presentation.
Okay. Assalamualaikum warahmatullahi wabarakatuh. The honorable all the judges, committee, attendee, and all the participants of logistics and supply chains competitions. Hello, we are a team from Pertamina University, consists of me, Osal Nur Taskia, Devan Davis Saputri, and Hanif Ashihuri. Thank you for the opportunity to present our supply chains model today.
I will explain the describe of the current supply chains of Kribo Noodle and initial situation. The first, PT Noodle Nusantara, initially the companies had change management facility in the form of one factory located in Cikarang, the 7 distribution warehouse located in Tanjung Priok Port, Merak Port, Tanjung Mas Port, Tanjung Perak, and then warehouse in Bandung, Yogyakarta, and Banyuwangi. And the second, supply chain design, which is a bad category. Why? Because the distribution from the Cikarang factory of the new 3 warehouse point has not yet found a defined route. And the last, the companies want to have an efficient supply chain design to achieve the target in the form of fulfilling demand for 30 days and maximum profit. But in initial state and supply chain design is already in the bad category, so the companies cannot achieve a more efficient supply chains. Next.
Okay. Wait. I'm sorry, still loading, sir. Okay. The next about the problem that happened in the model initially. The first is about the port of Tanjung Mas has a shortage of stock to meet demand per day on the first day and so on. We can see in the first day, total demand have 155, but the quantity on hand just 28. So it's mean that Tanjung Mas port have a shortages condition. The second problem is the type of transportation, number of shipment routes, delay between departures for the 3 newly built warehouses have not been planned yet.
Okay, for the strategy, there are several key points to ensure supply chain can responsibly cover all demands for more than 30 days and maximize the profit. There are inventory control, time control, and capacity of facility control. So what we did first is find the net requirement of demand in 30 days from the demand and on-hand data. Then we need to calculate how many trucks we need to deliver or the frequency of the truck it came by dividing the net requirement with the capacity of a truck that use. Then we calculate more. Is it possible for the truck to deliver front and back that many times in 30 days? Or we need to add the number of truck by considering the time travel and delay. Then we simulate these basic calculations in SCMGLOBE and make an adjustment for the design so it can perform well. After that, in a purpose to effective rent capacity, we change the maximum capacity of each facility so it can reduce cost and maximize the profit.
Okay, this is the analyze. In analyze, we will hear several terms. When here operating cost, meaning talking about cost incurred to carry out the daily activities of the companies carried out several activities. That's general operating costs, namely product activities, maintenance, and repair of equipment used for production and selling, marketing activities, raw material costs, and other activities that support daily activities that are directly related to the company's operating activities, which are of cost activities. And this figure about are the operating costs each facility. Next.
Harif still mute.
Okay, in the conclusion, based on the data processing carried out, this new supply chain model has been able to meet the company's goal of providing highly responsive services by being able to meet all requests according to the specified time and effectively in renting facilities and utilizing transportation modes. So that it has not been able to generate profits for the company. Increasing profits in this model can be done by further suppressing inventory at each facility so that the cost incurred by inventory can be reduced.
Okay, thank you for the Pertamina one to present your PowerPoint. Please stop share first. Okay, now we can continue to the Q&A session with the judges, please.
Hello, Hanif, Devanda, and Ocelia from University of Pertamina Team 1. So I see in your report, in your PDF report, designing optimal supply chain model with controlling inventory levels, production quantity, delay time, and transportation combination. Okay. I see that there's a lot of strategy that you use to try to gain the positive net profit. But I see that your team also have the negative net profit. I see in the result. So what do you think? What the cause of that net profit, negative net profit? What cause the biggest cause, the biggest contribution in to making that the net profit is negative?
Okay, thank you for the questions. We think the main problem with the case why most of the participants gain negative net profit is because the on-hand inventory on factory in Cikarang is not enough to cover the demand, the daily demand of all the warehouse and distribution center. So at the first, we already calculate the optimum order capacity, but when we simulate it in SCMGLOBE, there's a lot of problem that even cannot run from the first 0 days because of truck pick up too much from the factory. It's because the on-hand inventory cannot cover the day zero from day zero of the all demand. So we think if we want to increase the profit, we can make more on-hand inventory in Cikarang factory. So we can use the optimum order quantity for each distributions. And other problem we face is we only can use trucks, so it's so limited by the capacities and the speed of the truck itself. So if the next study case, I hope we can freely use other transportation modes such as rail freight, because in Java we see that there's a lot of rail freight. We can use it for the transportations. It can has bigger capacities and faster speed. And then the third problem is I think if we want to increase the net profit, we could build a new factory closer to Tanjung Perak warehouse and Banyuwangi distribution center, because it will be more effective than we spend a lot of time in the road for delivering from the Cikarang factory to the Banyuwangi, because it's from West Java to East Java, and that's spending too much time in the road, and that's not even effective. Yeah, that's three problems we face in solving this case.
Yeah, for your answer. We will let you design using the multimode in the final round. Hope you make it to the final round. So you can design your supply chain with the multimode. Okay. Any question?
Okay, interesting statement from you. You said that many other transportation modes. Okay, in reality, In reality, if you have a choice to use another transportation mode, what other transportation mode that you will choose and why?
Okay, thank you for the questions. I think the transportations I will use is the rail freight or the train, because a train has a faster speed and bigger capacity. So we could reduce the time travel, the time front and back of the transportation. So it could be minimize the cost of the vehicle, of course. And I think because in real life in Java there is a lot of rail, it's possible to use train in this case.
Okay. The first the first you said that because the capacity, right? Okay. The second.
The second is because the faster speed of the train. But it will be depending on what the specifications of the transportations mode defining in the case letter.
Okay. What major are you in?
We are from logistic engineering in Pertamina University.
Okay, logistic engineering. Have you tried another software before?
Not yet, and this is a great experience to try SCMGLOBE, so we can realistically see how our design and supply chains runs in real life.
Okay, thank you.
Okay, thank you. Now we will hear the feedback from Mr. Hugos, please.
Yes, I was impressed by the way that you took the on-hand inventory graphs and laid them out so you can see the flow of inventory through this supply chain. It's a good way to visualize what's going on. Whenever you notice that there's a lot of up and down spikes, that tells you maybe you have some opportunities to smooth out the flow of inventory. When you look, even when it is spiky, whenever it's going up, it means you're delivering more than what you need. Whenever it's going down, it means you're delivering less. So when you combine your mathematical analysis with your, trying things, letting the simulation show, try to level out, even if it's still spiky, try to level out your line, make it flat. Those are some good things, and you seem to be already doing that. So keep going.
Okay, thank you for your feedback. Thank you very much from University Pertamina Team 1, yeah. And I think I will say thank you and congratulations to all the participants in the semifinals. This is very, very good answer, and there's a lot of improvement, yeah, from the current supply chain. Thank you very much. Back to Pak Yodi.
Okay, this is end of presentation. Now, Bima as MC, please your time. Thank you.
Hello guys. How was the presentation? Is it very interesting? Is it very tiring? Well, now it's time to take a breath and also take a lunch break. We have around 1 hour for lunch break. So please have a great lunch, and we will be back at 1 o'clock. 1 o'clock for quiz. See you pretty soon. will start soon. Please wait. Welcome back, guys. I hope you had a great lunch, but don't be sleepy in these critical halls because now we will have quiz. The quiz will be led by Buira. Buira, time is yours.
Okay, thank you, Bima. We will have a quiz, for this day. Please join our quiz in here. Please click joinmyquiz.com and enter the join code. Okay, I will wait you for 2 minutes to join. Okay, we have one participant. Please join joinmyquiz.com and enter the join codes. We have 6 participants. Come on. Okay, I will wait for another 1 minute. Please join myquiz.com and enter the join code. Okay. Okay, I think I will start the quiz, please. There's 6 questions to answer, and we will have the winner. Okay, I will start right now. Okay. Okay, we have a winner. Congratulations. The first is Dewa Aditya, and the second is Nyoman Rati, and the third is CSS. Yeah, congratulations, and please contact the committee. Yeah, thank you. Back to Bima.
Thank you, Wira. Well, that was interesting quiz, right? Finally, we arrived to the moment of truth, which is the announcement for the finalists. Once again, I would like to invite judges to deliver the session. Pak Anggi, the floor is yours.
Okay, I will announce judges' decision. Based on presentation from each semi-finalist this morning, there were a lot of great analytic ideas. We really appreciate that all of the effort from all of you. However, we can only choose 3 finalists for the next stage. This decision is fixed and through fair assessment process. The indicator that we are evaluated most in this assessment are your assessment of the supply chain problem and your strategy for improvement. Net profit generated by your solution. And 3, transportation network design demonstrating creative and cost-effective use of product transportation option. So, here are the 3 finalists. First, Universitas Pertamina, Team 1. Second, Universitas Diponegoro, Team 5. Third, Institut Teknologi 10 November, Team 1. Congratulations and thank you very much.
Okay, congratulations to all the finalists and good luck for tomorrow.
Okay, thank you, Mr. Anggi and Bu Tati. Finally, we arrived at the end of this day event. Congratulations, the finalists, and keep up the spirit for those who are not through the final. Last word for me. Thank you very much for your participation. See you tomorrow and wassalamualaikum warahmatullahi wabarakatuh.